Hello everyone. Now we will discuss on the topic industrial pollution control in grossly polluting industries part 2. We will be focusing on the pollution control in distillery unit, and the content of this discussion will be general description, process flow sheet and molasses based process for distillery, source of wastewater streams, treatment methods, ETP flow sheet, ETP inlet outlet quality, sludge management, air and noise pollution. So, we will see the general aspect of distillery unit. Around the globe, the distillery produces ethanol or ethyl alcohol, and feedstock is used like sugarcane molasses or grains, or it may be beet sugar also. Okay. So, now this slide shows us the relative contribution of different grains and molasses for the ethanol production through the distillery unit. Okay. So, this is world ethanol production by different feedstock. We see coarse grain 56% and cane juice 32%, molasses 4% and non agricultural 3% and sugar beet 2% and wheat 3%. And if we see in Indian case, so molasses is 74% and grain is 26%. Okay. So, certainly we will be focusing mostly on molasses based distillery. So, what happens in case of distillery process? Sugar is converted to ethanol in presence of yeast microorganism, and monosaccharide and disaccharide present in the sugar molasses are actually responsible for this fermentation, and these are the chemical reactions, biochemical reactions which take place. So, cane sugar plus water, that can give us glucose fructose, and then C6H12O6 can give us ethanol and carbon dioxide, okay. And yeast works on this. The sugar industries, molasses produced in large quantities contain 40 to 45% fermentable sugar matter, which is made of disaccharide and monosaccharide. Cane juice also contains fermentable sugar in the range of 3 to 15% sugar. Okay. So, fermentation is done in the presence of yeast containing suitable enzyme such as invertage and zymase to produce ethanol. So, this is the reaction basically disaccharide to monosaccharide and monosaccharide to ethyl alcohol. And if we see the flow sheet for the production of distillery with the molasses or sugarcane molasses, then sugar mill produces molasses, then it comes to the distillery unit at feedstock, then after weighing, that molasses received and stored in the storage tank, and then molasses weighted in process and diluted with filter water, then diluted molasses which we will get. So, we have to add yeast. So, this molasses can be used for the yeast propagation with sterile wort, and then fermentation takes place. So, we are adding the yeast broth here in the fermenter, and then after fermentation we will be getting the conversion of sugar to ethanol, and then clarified wash which we are getting after the fermentation, that is going to decanter, and then sludge is going to bio-manure, and the liquid part which we are having, that is wash, that contains the ethanol, it is coming to analyzer column, and from this analyzer column this is heat is applied basically. So, we can get the rectified column, we can get the vaporized material which goes to rectification column, and the bottom part of its analyzer column gives us spent wash, which is the waste material that needs to be treated. And then after rectification column, so vapor is going as a rectified spirit, and then it is going to receiver, and then rectified spirit storage tank, and then issue head and issue of tankers. That means, we are getting the final product here, and that is rectified spirit. And if we want to get more pure product, it can go to molecular sieve dehydration bed, and then absolute alcohol, and then again it is going to the market. And in rectification column, we are getting one bottom product, that is spently, and here also we can get some fusel oil. So, this spently, then fusel oil is used, or the oil part is separated from this, and then it is marketed and sold in the market. And the spently, which is coming into the CPU, that is condensate polishing unit, that spent to us, which we have got here. This contains very high amount of organic content, and this is managed through different routes. Here it is shown for thermal route, basically it will go for evaporations in a multiple effect evaporator, and then condensation, the vapor part will be condensed, and then it will be sent to condensate, and that will be treated in the CPU. So, this is the major source of wastewater generation in the distillery unit when thermal power plant is used. If biological method is also used, then also there will be intermediate another step where biogas production will take place, but thereafter the same operation will also be there. So, then this is going to condenser polishing unit, that is your water treatment plant, and the concentrate from ME, that is having high organic content, and that is used with bagasse for cogeneration in the power plant, in the boiler, and then the steam is generated, and that steam is used in the process, and bagasse and concentrate is burnt in the furnace. And the reject from the ME, that is also coming and treated. Okay. And the UGR, which this UGR material basically from CPU, the permeate we are sending to UGR. So, UGR to this fermentation for dilution etcetera, this can be used. So, this is the overall flow sheet of the production of distillery, and we see the wastewater generation is taking place here, we have to take it care about, and then spently. So, that spently also, and other reject and your boiler blow down, those are the basic wastewater sources in this type of industry. Now, if we see the overall process, so it has molasses storage and handling unit, it will be having fermentation unit, distillation for production of rectified spirit ethanol, and then multi effect evaporator for the concentration of the spent wash. So, that one condensate will get as a water, and the concentrated solid, that is called spently, that is called slop, will be used with bagasse for cogeneration, and incineration boiler will be used for that purpose, and condensate polishing unit basically used for the treatment of the effluent or wastewater generated in the plant. And this is molasses storage and handling. Basically, distillery operates throughout the year, but sugar industry operates seasonally. So, in off season, to supply the molasses, industry needs to store very large amount of molasses, and the molasses may be of A, B and C type depending upon the concentration of sugar in it, and this is the first step. And then molasses fermentation, yeast propagation takes place, the growth of yeast takes place first, and then that is we have to take the dilute molasses media content in the yeast vessel, and that is heated to 85 to 90 degree centigrade with 30 minutes hold up time with hot steam and air purging. After that pasteurization cooling, water is passed through vessel jacket which cools the contents. Then yeast culture from the lab is transferred aseptically in vessel and grown till the specific gravity of the content reduces. Finally, yeast content from vessel is transferred to pre-fermenter, and this pre-fermenter, the grown yeast is transferred to pre-fermentation stage for further propagation, and then it comes to fermentation, where certain condition is maintained, so that yeast will be working perfectly on the sugar present in the fermentation media. Temperature is maintained to 33 to 35 degree centigrade, and the average fermentation time is 22 to 24 hours, and after this fermentation the fermented wash that contains 12 to 10 to 12.5% of alcohol. So, this is the fermentation unit, and then distillation unit. So, multi pressure rectifier distillation system is used for the production of rectified spirit. Basically, our objective will be to produce a rectified spirit, and then in the second step we are interested to produce more pure alcohol. So, more than 99% pure alcohol. So, in that case we need distillation column. So, there are 3 columns, namely analyzer or degasifying, and then aldehyde and rectifier come exhaust column. So, we are present in this distillery unit, and the fermented wash which is fed to top of the degasifying column is operated under vacuum. The wash is then fed to analyzer column, and the vapors from the top of the analyzer column are used in rectifier cum exhaust column operated under pressure. The steam is given to the rectifier cum exhaust column through reboiler, that is live steam, and the rectifier vapor is used to heat the analyzer bottom, which is also termed as spent wash. That concentration, it is having 12 degree Brix, and the rectifier bottom generates spent lees. So, alcohol is enriched towards the top and is drawn out at as rectified spirit at about 95% concentration from rectifier cum exhaust column. Further purification 99.5 to 99.9% alcohol is done through molecular sieves. Fusel oil buildup is separated in the rectifier cum exhaust column by withdrawing outside streams. These are sent to the fusel oil decanter, where these streams are diluted with water and fusel oil rich layer is separated. The fusel oil wash water is recycled back to the column. So, this is the process, and multi effect evaporator, that is the main role is to concentrate the spent wash. So, what we have, that is 12 degree Brix, 13 degree Brix spent wash is concentrated to 58 to 60 degree Brix by this multi effect evaporator, and this after this it will give us condensate, that will go for CPU for treatment, water treatment, and it will give us the concentrate, the slop, that will be used in the boiler for cogeneration with bagasse. And incineration boiler, that is concentrated spent wash is fed to the boiler with bagasse to generate steam. Now, we will see the sources of wastewater streams which are generated in a distillery unit. So, main is your spent wash, we see very high COD and BOD concentration. Then fermenter cleaning, that is also having BOD and COD relatively higher. Fermenter cooling, then condenser cooling, and then floor washing, and then your bottling plant and others, that is the characteristic COD 250, BOD 30, SS 100 and P. So, these are very low organic containing water. And bottling plant, in the fermentation process carbon dioxide is produced, and that carbon dioxide is bottled in a purified and bottled, and that is called bottling plant. And in this case the wastewater which is generated COD 250, Mg BOD 10, SS 150 and pH 7.6. So, this also does not require much treatment. So, spent wash and Lee, spent Lee, those are required for the treatment. So, in a conventional process all these can be mixed and can be sent to the wastewater treatment plant or CPU. Some other wastewater which is generated in the boiler and in the tertiary units like say microfiltration, ultrafiltrations, reverse osmosis processes. So, those residual part can be used with the for ash management generated in the boiler or can be treated further in the CPU, the second part of the CPU. So, it seems that the spent wash contains maximum COD/BOD and color with respect to other types of wastewater, and the wastewater from bottling plant does not need any treatment as the concentration of COD/BOD TSS are below the permissible limits. Other types of wastewater require treatment, although the concentrations of the contaminants are less. Thus, except the wastewater from bottling plant, others may be mixed and can be treated through suitable techniques. The dark brown color of the spent wash is basically due to the presence of brown pigments, that is melanoidins, produced from Maillard reaction of sugar with proteins, caramels and furfural acid hydrolysis. So, favorable conditions for the Maillard reactions, non-enzymatic reactions are temperature greater than 50 degree centigrade, pH 4 to 7 prevailing during the process, and this is the treatment scheme. So, distillery wastewater which we are getting, that can be directly evaporated, that is spent wash, then it will give one condensate and another will be concentrate. So, that concentrate will go for incineration and potassium recovery, and it will give us condensate that will go to CPU for water treatment. And another route biomethanation. So, biogas will be produced first and then the slurry which we are getting, that can be further evaporated and in the same way it can be processed, or it can be going for 2 stage aerobic treatment and then tertiary treatment, surface water discharge. After the biogas production, the sludge which will be generated, that can be used as the manure production, also as the can be used also for the composting purpose. So, that is the biomethanation based method and evaporation based method. There are two basic type of methods, and when we go for biomethanation based method, then the composting is one important process that produces biofertilizer from the residual part of the biomethanation unit, and it requires very large area, and in rainy season also there is a good chance of the water runoff and the contamination of the river water. So, in India the incineration based methods, that is the direct evaporation based method, evaporation based method is preferred, and CPCB has recommended the use of this evaporation based method, and thus more focus is on to use the thermal method or evaporation based method in larger extent. Now, we will see in case of this evaporation based methods. So, different waste stream we are having spent wash, fermenter washing or floor washing, RO reject, cooling tower blow down, spently and process condensate. So, these are the disposal or utilization options. The spent wash ME multi effect evaporator, and then the condensate is going for CPU and solid is going for incineration. The concentrate is going to the incineration boiler, and then fermenter washing, floor washing stored in lagoon before entering ME and goes to lagoon for ME feed, and RO reject can be used for ash management and goes to RO reject storage tank and used for ash management and ME feed. That from plant to plant it may varies, somewhere this goes to ME as a feed, or in some cases it goes directly to the boiler with the bagasse. And cooling tower blow down, tertiary treatment, and this enters into the water treatment plant, but not in the primary and secondary step. Okay. And then Spenley and process condensate are used in the CPU. and ZLD is compulsory, that is zero liquid discharge is compulsory for distillery unit in India, and in this case the use of MEE is must, multi effect evaporator, and in case of multi effect evaporators, as you have discussed, that 13.5 to 17 breaks, somewhere 12 to 13 breaks, okay, that is converted to 58 to 60 degree bricks, okay, and the spent wash is having these characteristics, COD concentrations and this temperature and pH. So, when it goes through the MAE, so it is concentrated up to 58 to 60 degree bricks, and the performance of the ME will depend on many factors, that is the feed temperature, steam temperature and pressure, steam economy, cleaning of evaporator are some important factors which influence the performance of ME, and the condensate of ME plant, spent leach and cooling tower blow down are treated in CPU, and this is the CPU unit, the process flow diagram of wastewater treatment in the distillery unit. So, ME condensate and spent leach is coming, it is equalization tank first step, then conditioning tank, then pH adjustment etcetera. Then it is going to ICX, that is bio tower, biological conversion. So, here the biogas is produced, it is flayed, and the supernatant liquid is coming for aeration tank. So, here aerobic digestion. So, anaerobic degradation, then followed by aerobic degradation in this aeration tank by the use of some aerobic microorganisms. So, organic content will further be reduced, then it is going for secondary clarifier. So, from secondary clarifier it is going for HRSCC, hydrate solid contact clarifier, and then it is coming to tertiary unit, that is MGF and then ACF. So, these are the filters and then back to bed filters, then it is coming to UF and RO, and which is ultimately passing through UV for disinfection and used in the plant for your dilution of the molasses and other activities. And as I mentioned that cooling tower blow down, that is entering here, that is escaping this primary and secondary step, directly it is entering into the HRSCC unit, and then it is going for tertiary treatment. And this process in CPU, in this process influent containing mixture of spent leach and ME condensate enters into the equalization tank with retention time of around 6 hours. Therefore, it goes to conditioning tank through plate heat exchanger, temperature at temperature less than 35 degree centigrade for chemical dosing to neutralize pH of the stream, pH 7.6, and after this wastewater enters into anaerobic digester for anaerobic treatment. In this digester biogas is formed, COD is reduced by 90% or more. The biogas is stored and managed through flaring. The residual part is sent to the aeration tank for aerobic treatment through activated sludge process. After aeration, the separation of sludge takes place in secondary clarifier, and the supernatant water mixed with cooling tower blow down goes to tertiary clarifier field, followed by MGF, ACF and UF. After this tertiary treatment, some part of the treated water is passed through UV unit and used for molasses dilution in process. Rest of the treated water is further treated through RO for application in cooling tower. The sludge generated in the plant is filtered through a centrifuge, and the cake is used for the bio-manure production, and the filtrate goes to aeration tank. The RO reject is used for ash quenching spray on bagasse, and balance is fed in ME, multi effect evaporator. This slide shows us the requirement of different treatment units for 1300 KLD plant, CPU plant, 1300 KLD treatment capacity, different units, and their typical size which are required and number of units is provided. And ETP, inlet and outlet quality, typically it is given, then the CPU inlet is the temperature, pH, TDS, TSS, BOD, COD, it is given here, and after treatment it produces like this. So, all are below permissible limit, and moreover CPCB has recommended that there will be 0 liquid discharge from this distillery unit, and all water which is generated, that is recycled and used in the plant itself. Then we are coming to sludge management. So, sludge management, which we are seeing that in the CPU unit we are having some sludge that is used after dewatering, it is used for the bio-manure production, and in case of biodigestion route, the spent waste treatment for in case of biodigestion route for spent waste treatment, the biodigested sludge is mixed with press mud generated in sugar unit and processed through biocomposting. So, that is another process where biocomposting route is followed, that is biodigestion route is followed, and the biocompost is used as fertilizer. And in evaporation route for spent waste treatment, the concentrated spent waste or slop is used for cogeneration in boiler with bagasse or other fuel, and sludge as CPU is used as manure. So, these are the different sludge which are produced in the plant, and those are used in different way. This is showing one biocomposting plant, and this is your furnace where cogeneration takes place, and boiler ash which is generated in this furnace or boiler, the ash which is generated, that contains 14 to 22% potash, and it is mixed with press mud and filtered sludge to produce biomanure, or it is also used as fertilizer. Then air and noise pollution control. So, main sources for air is cogeneration in power boilers and evaporators. So, air pollution main source, the main sources of air pollution are cogeneration in power boilers and evaporators. Cogeneration produces the emission of pollutants such as sulfur dioxide, carbon monoxide, nitrogen oxides, and typical values for SPM 34.8 mg per normal meter cube, SO2 30.9 mg per normal meter cube, NOx 65.4 mg per normal meter cube, CO2 0.22 mg per normal meter cube, and CO2 generation in fermentation process is collected, processed and sold, as we have mentioned earlier. 5 major noise sources are steam venting, steam leaks, shredders, evaporator washing and power generation. And air pollution equipment should be installed for air pollution control. Proper stack height should be maintained as shown here. So, that is 80 feet 100 feet long stack is needed, and appropriate measures should be taken to reduce the noise level, such as using silencer in boiler, providing hearing protection devices, etc. So, these are the different aspects of the distillery units and the pollution control of distillery unit we have discussed. Up to this in this class, thank you very much for your patience.